Let's look at some basic calculations involving the joint life. I have to do them using the PMA 92C20 table. Okay, a simple calculation of mu 6560 is nothing but I can write it as mu 65 plus mu 60. So I can get the values from there, we'll get them and we'll do the summation. Similarly, 5p65 colon 60, I can write it as 5p65 times 5p60, which means I will write it as L70 by L65 multiplied by L65 by L60. And as I have to take both of them as males itself, I could very well take it as L70 by L60. Similarly, when I want to go with 2Q6565, it is basically that one of the lives is going to die between 65 and 65. So I can very well take it as half of 2Q6565, and this will become half of 1 minus of 2p65 colon 65, and this will become half of 1 minus of 2p65 multiplied by 2p65, right? So which is as good as 1 minus of L67 squared by L65 squared. Let's try to substitute the numbers and simplify the calculations from PMA 92C20 table. Right, PMA 92C20 table, I can very well pull out all these values. So first of all, I require mu 65. I also require mu 60. For the second question, I require L70 and L60. For the next one, I require L67 as well as L65. If I have all these, I think we can very well solve all the numericals that are being asked for. So mu 65 for a male is 0.005543. Mu 60 is around 0.002266. Then if I am looking at L70, it is 9238.134. L60 is 9826.131. Then we have L67, which is 9521.065, and L65 is 9647.797. So all these are helping me out to solve my numerical, right? Mu 65 colon 60 is simply the summation. So it is mu 65 plus mu 60, working out to this much. Then 5p 65 colon 60, if I have to look at, it is nothing but L70 divided by L60, which is working out to 0.940. And finally, I can look at 2Q 65 colon 65, where the first person only is died. So it comes out as half times 1 minus of L67 squared divided by L65 squared, which is working out to 0.0130, whatever. So these are the typical computations for this simplified numerical for us, right?